Hello everyone, this is John Elder again with another service video. Today we're going to talk about installing a wall mount control package and some basic wiring to get the job done. Be sure to follow all safe work practices, especially the use of PPE. All circuits should be de-energized prior to any wiring or service. Remember, many of our controls will have more than one circuit that will need to be turned off. After de-energizing a circuit, verify that the circuit is dead, then lock out and tag the breaker. So this whole video started with a control package that we had here in the display center. Control package we'd used for training for a number of years. It had been wired, rewired, unwired, disconnected, changed, parts changed, whole 9 yards. It's a little outdated. So what we did is we ordered a duplicate control package. So this is the new package that we have here. I've already mounted it on the wall. I've already got it all wired up and ready to go for this video. I want to talk about location. When you're mounting a wall mount control package, you can mount it anywhere in the building. You typically want to mount it in a convenient location as close to the equipment that it's supporting. But you also need to think about service. This package is going to have to be accessed for service at some point, so you want to locate it in a good location. This is the display, or the digital display of the control package, to be able to turn the lights on, fans on. If you hang this package up near the ceiling, obviously this is not accessible. This can be relocated. This is what we call the HMI. That can be relocated. It's simply a Cat5 cable, and can be relocated to a 2-gang box anywhere, either surface mounted on the wall, recessed, manager's office, wherever it's a good location. So just be aware of that. You can relocate this. You put a stainless steel blank on here to cover up the hole. So now let's talk about mounting the control package. You want to use adequate hardware to hang it on the wall. You don't want this thing falling off the wall, obviously. Obviously, you don't want your conduit to hold it on the wall either. So it has to be mounted with adequate hardware. Once you get it all mounted up and it's hanging on the wall, the next step is wiring. So what we've done is we've brought in our 3 circuits here. This is from our breaker panel. We have 3 VFDs in this control package. This package is going to be similar to what you have on your job site. It might not. Just remember, every job is custom built. So every control package is custom built. So the package that I have here may or may not match your package exactly, but the general principles are going to apply. So we have 3 VFDs, and then we need power for our control board right here. So we have 4 circuits coming into this panel. 3 conduit, 1 conduit has 2 circuits in it. That's okay. So what we have is we have 208 3-phase power, 208 3-phase power here, 208 3-phase power plus a 120 volt control circuit. The 120 volt control circuit lands here on H1 and N1. That's this black and this white wire right here. This is 120 volt control, powers our power supply, provides power to the board. It's the brains of the whole unit. And then you have a separate breaker for each VFD. That's true for any control package, no matter how many VFDs you have, whether you have VFDs or not. Every fan has to have its own breaker, and the control board itself has to have its own breaker. You can't share breakers, especially with VFDs in this case. The 120 volt circuit terminates here on H1 and N1 terminals, and the 208 3-phase terminals are here at the VFD quick disconnects. Care should be taken to ensure that you're wiring the line power to the proper terminals, or immediate damage will occur if power is applied. All the terminals are labeled, so identification should be easy. Moving on to the power for the control package to the fans. Again, in our example here, we're utilizing VFDs, so wire must be run from each VFD to the correct fan, and the load wiring must be run in separate conduit from the VFD to the fan. When using the VFD, the load wiring cannot share any common conduit or junction boxes. Doing so causes interference in the power to the fan motors and will cause premature motor failure. The line power from the breaker panel can be run in the same conduit because it's constant power, but load wiring has varying power and must not be combined. Refer again to the wiring diagram to ensure you're wiring the correct VFD to the correct fan so the system will run properly. Now that the fans are wired, let's look at the other wiring requirements. First, I'm going to cover all the 120 volt circuits. If your project has standard Ansel fire system, the microswitch should be wired to terminals C1 and AR1 and wired normally closed. Next are the hood lights. All the hood lights get wired together and terminated here at B1 and W1 and ground. The light circuit must not exceed 1400 watts. The shunt trip breaker coil is wired to terminals ST and N1 here. If you're using a contactor to control the power to the appliances under the hood, you can wire the coil to either terminals AR1 and N1, or if your control package has the option, like mine does here, you can wire to KS and N1. If the hood system is using a dedicated makeup air unit, check the wiring diagram of the unit to see if you need to wire a 120 volt circuit from terminals SF1 and N1 to the makeup air unit, or if the system utilizes the dry set of contacts SFC1 or SFO1. Now let's look at the low voltage requirements. First is the damper interlock switch, if applicable, from the makeup air unit to the circuit board. This is a 24 volt circuit from the control board, from IL1A up to the damper switch, back to IL1B. Some dedicated makeup air units use a dry set of contacts, SFC1 and SFO1, rather than the damper interlock switch. So be sure to study the wiring diagram on your makeup air unit to know what your particular system is using. The next low voltage circuits are the temperature sensors. Starting with the room sensor, you will have one or two types. The first is a wired temperature sensor that should be mounted on a wall that will give an average temperature of the kitchen. All temp sensors are 10K thermistors and are terminated on the T terminals located here. The second type of room sensor is a wireless sensor. The receiving unit for the sensor will already be wired from the factory and in the control package. And to activate the room sensor, you'll have to plug in the battery and ensure the mounting location receives at least 200 lumens of light to keep the battery charged. The next temp sensor needed will be in the hood system itself. These sensors may already be mounted in the exhaust risers of the hood or may be shipped loose for field install. In our project, our sensors were shipped loose and were mounted directly to the control package, as it's for demonstration purposes only. So that's it for the install. Remember to check your wiring diagram, make sure you got everything covered that you need for the whole system. Everything's wired up, everything's going to work properly. Don't apply power though to this control package until you watch the video on how to safely apply power to the control package. If for some reason some wires got crossed, something got wrong, you got a wire in the wrong place, you could destroy a VFD instantly. So I hope this video made your install go a little bit smoother. If you have any questions on this product or any of our products, you can call or email our tech support group. So thanks for watching.